Hey guys, Math 1500 standardized scores, also known as z-scores. Um, let's uh, let's begin by just thinking about kind of where we are with these normal distributions. If we go out, and collect a random sample, and one of the first things we may want to do is construct a box plot and maybe a histogram. And let's just say, for example, that we construct a histogram for our sample. And we get something that looks like this. Well, without question, we would, I'm not talented enough to write and speak at the same time, but without question, we would refer to this distribution as being bell-shaped and symmetric. And the most appropriate measure of center that would report for this distribution would be the mean, and the corresponding measure of spread that we would report would be the standard deviation. Now, that's not even really true. Let me back up. We would always report the mean, the median, the standard deviation, the quartiles, IQR, the range, so on and so forth for this distribution. But the two measures of center and spread that we would depend on to make important decisions about our distribution would more than likely be the mean and the standard deviation. Okay, so we report it all, but the two best measures would be the mean and the standard deviation. Now, if we were going to calculate a z-score for some observation, and let's just call it x, from this distribution, so it's like one score, right? Uh, we would take the observation minus the mean and divide it by the standard deviation. Now, as we move into the study of populations, and what you're going to find the rest of this class is that we're going to explore this dynamic between samples and populations pretty much ad nauseum. Um, so that just keep that in mind. So, guys, if we had information about population, and the mindset you've got to take from here on out is this sample over here is collectible. We can go out into a larger population. For example, let's say we want to know what percentage of likely voters in a state are going to vote for candidate A or B or C or whatever it may be. We can go out and get a sample of 1,000 people and ask them who they're going to vote for. They may lie to us. They may not tell us. They may be deceptive, but we can ask them. We can get a sample. If we want to go out and get a sample of 1,000 students, college students in the state of Ohio, and give them an IQ test, for example, or an ACT test, we can do that. Create a histogram. We can get the mean for the sample. We can get the standard deviation for the sample, and we can calculate a z-score for any particular person in our sample. Now, population, the mindset you've got to take is we have this, this distribution that, in a sense, is unattainable. We can't go out and collect information on every single uh, subject, element, dogs, cats, trees, whatever it may be, in our distribution. But we have these probability distributions, specifically the one we're looking at is called a normal distribution, that represents or summarizes, I guess would be a better way of putting it, uh, the scores in our population, the measurements in our population, if we were able to construct a histogram for them. Now, instead of bell-shaped and symmetric being kind of loosely defined over here, what we call this in statistics is we call these a normal distribution. Now, just as you would think, if x bar is the best measure of center for a bell-shaped and symmetric distribution, then the corresponding mean, which is mu, would be the best measure of center for the normal distribution. Standard deviation, the corresponding notation for standard deviation in a population is sigma. So this is a population mean, population standard deviation, population mean, population standard deviation. Z-scores from I said that totally wrong. Population mean, population standard deviation, sample mean, sample standard deviation. So if I'm going to calculate a z-score for a sample, I take the observation minus the sample mean divided by the sample standard deviation. Well, guys, it should follow that if I'm going to calculate the z-score for an observation from the population, I'm going to take the observation, the measurement of the one observation minus the mean divided by the standard deviation. Okay? Gotta tell you kind of a funny story, or at least I think it's kind of funny. I was talking to a colleague the other day, and she was telling me that, and this is a colleague I really like. She's not only a respected colleague, I consider her a friend, so I like her personally and professionally, which isn't, I guess always the case, but here at Shawnee it usually is. But she was telling me that she said, "You'll never guess what I did the other night." And I'm like, "I have no clue." And she said, "I watched your videos, and all I could think was, I'm so sorry. I'm sorry I ruined your night." So you never know. I noticed the other day someone from Brazil is now following me on YouTube, and there was someone I think from India. It's crazy the people that are kind of out there watching some of this stuff. So guys, accept my apologies. do do the best I can and try to keep these things lively and entertaining. But keep in mind, I'm really kind of boring. All right, gang. Let's just start out with something we know. We know that IQs form a normal distribution with a mean of 100, standard deviation 15. Now, we'll tell you that some of the studies coming out recently are saying that this standard deviation is very likely 16 instead of 15. But let's just keep it 15 to make these calculations. So the first problem I'd like to look at is calculate the z-score for a person with IQ equal to 122. Well, we can think of this IQ equal 122, we can think of that using the notation from the previous page as our x. So guys, the z-score would be very easy to calculate. We would just take the score that we want to calculate the z-score of, minus the mean, divided by the standard deviation. Now, this is an elementary exercise with your calculator, as long as you don't get goofy on me, and and do something like this. And I'm just going to point out what's completely wrong. If you wake up tomorrow and just want to do statistics wrong and get bad grades and miss easy questions, do this. You'll achieve your goal. That's completely wrong. If you hit that, you're going to get something goofy like 115.33. What that's doing is that's actually taking 100 divided by 15 and then subtracting that from 122. Well, guys, we don't want that. We want the 122 minus the 100 to be calculated, and then we want to divide this by 15. So in this case, we get a z-score of 1.466666 repeating. Z-scores should be considered a descriptive statistic measurement, and consistently we round those to two places. So I'm going to round this to 1.47. And what we can say here is we can say that an IQ of 122 is 1.47 standard deviations above the mean. All right, it's that easy. It is that easy, boys and girls. Now, sometimes we're asked to change things up a little bit. Let's say we have a distribution We have a normal distribution with unknown mean mu with sigma equal to 10. Find the mean. If we know that a score of 100 is 1.82 standard deviations, below the mean. Okay? So what all do I know here? What do I know for sure? Well, I know my mean is unknown. I know my standard deviation is equal to 10. I know that my score from the distribution is 100. And I know that its z-score has to be negative 1.82 because it is below the mean. All right, so guys, simple plug and chug here. The z-score formula, as we know, is x minus mu divided by sigma. So we know that for this problem that the z-score is negative 1.82, and that must correspond to a score of 100 in a distribution that currently the mean is unknown, and we have a standard deviation equal to 10. Well, guys, what I would do here is I would multiply both sides by 10 first, as you would expect. These are going to, as you guys like to say, cancel out. So on the left-hand side, I'm just going to go ahead and take care of this. I can do this in my head, but maybe you can't. And if you can't, don't sweat it. It's not a big deal. I guarantee you have talents that I don't have. Numbers, math, this just always kind of been stuff that's come easy to me. But you know, other things don't. So when I multiply negative 1.82, I get negative 18.2. And notice, guys, that the negative I put there is not this one, which is a subtraction sign. Anytime with your calculator you start a number with a negative sign, you got to use this one down here. For example, let's say I screw up. I put that one right there. Okay, let's stop. Let's say I put that one right there. Okay, that's not cool. I want that. Let's go. Let's get rid of the answer part. Okay, so I've got that negative right there, and I put 1.82 times 10. It's going to give me an error because I have the wrong negative sign. So I can hit go to, and it's going to show me where the error is in that expression. So best thing to do is just don't let that happen. Always, if you're leading with a negative, lead with that one. All right, gang, so negative 18.2. And on the right-hand side, what we're left with is 100 minus mu. Now, from here, it's just hard for me as a professor, as a teacher, to know what step to tell you to do next. We could add 100 to both sides and then multiply both sides by negative 1, or we could take the negative mu and add mu to both sides, in which case I'm going to get mu minus 18.2 equals 100. Add 18.2 to both sides, and I get mu equals 118.2. You could also up here have subtracted 100 from both sides, in which case you would get negative 118.2 equal negative mu, but again, you're trying to solve for mu, so you'd have to multiply both sides by negative 1. Either way is fine, as long as you're consistent with that. Okay, so guys, just an illustration of how to solve a problem where the mean is unknown, but the The relationship between the score and the z-score is provided. Now, one more thing I want you to think about. I want you to think about getting a picture. It's going to be a short video. I've probably got 2 to 3 more minutes. I'm going to talk here. What what I want you to think about is the picture of what we call raw scores. And when I talk about raw scores in the context of normal distributions, what I want you to think about are like IQs, gestation periods, ACTs, any sort of numerical measurement that I tell you forms a normal distribution. And what happens here is we get this normal distribution where we know smack dab in the center is the mean. We come over here to where we have this kind of linear tendency. That's 1 standard deviation above the mean. That's 2 standard deviations above the mean. 3 standard deviations above the mean. Same thing here. Look for that linear part. The mean minus the standard deviation. Minus 2 standard deviations. Minus 3 standard deviations. So guys, we could go 4 above, 4 standard deviations above, 5 above, 6 above, 7 above, 4 below, 5 below, and so on. But typically when we're sketching these things out, we just go to 3 below and 3 above. And the main reason is almost all of our information in this distribution is accounted for between 3 standard deviations below and 3 standard deviations above. 997 out of every 1,000 measurements in this distribution falls between 3 standard deviations below and 3 above. Now, what I want you to think about is these things are interchangeable with this z-score distribution. And the z-score distribution has mean equals 0, standard deviation equal to 1. So whatever score represents the mean, it's going to be mapped to a z-score of 0. Any score that represents 1 standard deviation above the mean is going to be mapped to a z-score of 1, because a z-score is precisely that. It tells us how far above the mean in standard deviations that a score falls. Whatever score we have right here, the score that's 2 standard deviations above the mean, well guys, it's going to have, down in this distribution, it's going to have a score of 2. Now over here we have the mean minus a standard deviation, so this score is 1 standard deviation below the mean. Well, because of that, it's going to kind of map to a score of -1 down here. So guys, it doesn't matter whether we've got IQs, gestation periods, ACTs, whatever score is 1 standard deviation above the mean, it's going to have a z-score of 1 because it's 1 standard deviation above the mean. Now, show you a question I gave on an exam once. I don't know if it's going to be on your exam, but if it is, lucky you. And for the most part, the score said something about a score from a distribution has z-score of -1.5. The mean is 250 with standard deviation equal to 20. The only score that could correspond to this z-score, from the following choices. And I don't remember what the distractors were, or what the questions were, or what the choice of answers were, but it was something like this. Okay. Now, I was really shocked that this was one of the most commonly missed questions on the exam. Because, first of all, if you have a z-score that's negative, it is a no-brainer that that particular x has to be below the mean. The mean's 250. It's given right here. If you have a positive z-score, then that score has to be above the mean, which is 250. If you have a z-score that's 0, then that would be equal to the mean of 250. So to me, that was a really easy question, and the answer here should have been A because of all the choices. The only score that was below the mean of 250 was 180. But I was really shocked that that was a commonly missed problem. So guys, that's it. That's pretty much all I got for you in this video. So that's a short video, the kind we like, right? All right, guys, take care.